Hi, I'm Sai Krishna. So let us look at the question number 2. In question number 2, we are given joint density function as 1 by a y square x. We are also given that y is greater than or equal to 1, and the relation and also x varies between 1 by y and y. So let us look at the question number part 1 of question number 2, which states that we have to draw the non-zero definition region of density joint density function. So let us look at the solution for this. So for in the solution for this, I've drawn the 1 by x equal to 1 by y graph, and also x equal to y graph. That is because here the x is ranging between 1 by y and y. We are also told that we have to find a region where x is greater than this is the region. So this is the region where x is greater than 1 by y and less than y. So I've taken this non-zero region as the solution for the part 1. So in the part 2 of the question, we are told to calculate the value of a, so that fxy is a valid joint density function. For this to happen, we have a relation where double integral 0 to infinity joint density function area should be equal to 1. Okay, so I've basically substituted the value of joint density function, which is given as 1 by a y square x, and then we are also told here that x is ranging between 1 by y and y, so I've substituted it here, 1 by y to y. So I've calculated this area. This turns out to be uh, log log 2 log y. Okay, and also I've separated a 1 by a here because a is a constant. So now we have to, now for the second integral, I have taken it as 1 to infinity because here y is ranging, y can be anything greater than or equal to 1. So it is the lower end, the lower limit of the integral is 1 and the upper limit is infinity. So by that I've calculated it as 2 by a equal to 1 and a equal to 2. I've got the answer as a equal to 2. So let us look at the part 3. In part 3, we are told to calculate the marginal density functions f of x and f of y. So for the marginal density function, we know that marginal density function of x can be written as integral minus infinity to infinity joint density function fxy dy. So it is basically we have taken the interval here as 0 less than or less than x less than 1. Okay, and I've substituted the value of density function of joint density function and dy. I've taken the integral limits from 1 by x to infinity because we can see that here the function, the lower limit of the lower limit is 1 by x and the upper limit is infinity. So I've taken it and substituted it. I've got the answer as 1 by 2. So this is only between the intervals 0 to 1, because here we have an interval where 1 is like the limiting factor here. So I've taken it between 0 and 1. So now comes the limit where we have to calculate the value of x, which is less than greater than 1 and infinity. X lies between 1 and infinity. So I've substituted x and infinity and then calculated it. It turns out to be 1 by 2 x square. So I've drawn the graph for it. Here between 0 and 1 it is 1 by 2. So I've drawn a straight line, and then it is 1 by 2 x square. So it is a decreasing graph. So in this way I've calculated the value of marginal density function of x. Now we have to calculate the marginal density function of y as well. I have applied the same formula, integral minus infinity to infinity joint density function dx here. So I have calculated it because we are given that x is ranging between 1 by y and y. So I've substituted it as 1 by y. So I've substituted the value of joint density function and then plotted the graph. So let us look at the question number submit 4, where we have to verify that f of x and f of y are valid density functions. So for them, for a particular thing, for being a valid density function, then the integral area should be equal to 1. So here I'm first calculating the value of f of y, the marginal density function of y dy equal to 1, and I've taken the integrals from 1 to infinity because here we are given that y is anything between anything greater than or equal to 1. So I've taken it as 1 to infinity and I've substituted the value of marginal density function of y. Okay, and I've calculated the value, which turns out to be 1. So it's a valid probability, valid density function. Okay, so let us look at the marginal density function of x. For that to happen, the integral minus infinity to infinity marginal density function dx must be equal to 1. So which turns out to be 1 as well here, because it's 0 to 1 and 1 to infinity, and so both the functions are valid probability density functions. So in this we have calculated the question number 2. Thank you.